Good afternoon and happy Friday, and welcome to today's webinar, The Key to Running a Top-Down Design Process. My name is Rob Romanowski with 3HTI, and I'm also joined today by two 3HTI experts in the field of top-down design and the specific tool that is used for top-down design called the Advanced Assembly Extension. That would be Jim Gilmore and Joe DiCarlo. And also doing an overview and presentation for us today from PTC is Jonathan Conklin. So we're glad that everybody could make it today. And if you have any questions, feel free to type those into the dashboard, and we will try to answer them as we go along. So first off, just real quick, for those of you who may not be familiar with 3HTI, we're a systems integrator with a focus of helping discrete manufacturing companies in all phases of product development, from design through manufacturing. And this includes analysis and end of life cycle for products. So our goal is to help our partners operate more effectively and efficiently, improve profits, and overall become leaders within their respective industries. Now, the software and 3D printing solutions that we provide help with the digital transformation of taking concepts and ideas and transforming them into a digital file that can be used for augmented reality, for additive manufacturing or 3D printing, and analysis, or any other way that the part or the assembly is shared with others inside and outside of the enterprise. So as I mentioned, we're going to take a look at this, take a look at the Advanced Assembly extension from PTC for Creo. And basically this, you're basically from top-down design planning out a skeleton of the assembly so that the individual components are designed in the context of the overall structure. And this results in the complexity of managing various relationships between components becomes simplified. So what I don't want to do is take away from Jonathan's thunder. I'm going to pass everything over to him, and then he can take control. And Jonathan is an applications engineer from PTC, and he does a great job with these presentations. So really glad that he could be with us today. So Jonathan, I just passed everything over to you.
Great, thanks. Let me set everything up, and let me know when you can see my screen, and we'll get started.
You got it. I see the PTC screen and the Advanced Assembly Extension. Perfect.
Okay, like Rob said, my name is Jonathan Conklin. I'm a pre-sales technical specialist or applications engineer, whatever you want to call it, here at PTC. And I guess my job today is to talk a little bit about our Advanced Assembly Extension and how you can utilize it to really up your game whenever you're working with very complex models and assemblies, and just make your life a lot easier. So the way this demonstration is going to go is I have a couple of slides that are just going to introduce some challenges people are working with today. I'll introduce what the extension is, what the capabilities are, and then we'll actually jump into a demonstration within the software just to get our feet a little dirty and see how you would use it in the day in the life of an engineer, excuse me. So without further ado, let's jump right into it. And if you guys have any questions, feel free to put them in the chat, and we'll discuss them at the end as we go along. So let's get started. So some of the challenges that are surrounding concept design okay, looks like, can you guys hear me?
Yeah, sorry about that. I went to mute myself and I accidentally hit you. Sorry, Jonathan.
All good. Okay, so again, the challenges arise whenever you're trying to assemble many different parts together, as you typically do as a design engineer. So when you start out with 20 parts, that's pretty simple. It doesn't really matter the design intent that you have in the background. You can pretty easily put those all together. But the problem really arises whenever you start to up the ante. So let's say you're working with 200 parts. Okay, you could probably do it, but what happens when you get some things downstream and you get some calls from different engineers and they say, hey, we need to swap out this part, or we're making modifications to this part. How is that going to interact with your assembly that you have put together? Well, with 200 parts, it's still viable, but it becomes a lot more of a headache. You may spend half a day to a day trying to fix it, depending on how in depth the problem is. But let's take it a step further. Let's say you're working with 20,000 parts. You're working with a really complex design such as what you see in the screen. Working without having the design intent there or not having top-down practices in place, it's going to be a nightmare trying to make modifications or just trying to update data. And so this is something that a lot of customers and a lot of people who aren't using this extension have been talking about. They've been saying, we're having a lot of difficulties with our assemblies, and we need a solution that is going to facilitate our needs. So again, when you're working with large assemblies, the models they can be slow to work with in the beginning. So having to load them in and out of sessions or trying to make modifications that I was talking about before, it can be a really daunting process and a very time-consuming process. And so what really needs to happen, you need these tools. This is what I was talking about before. You need these tools and formal methodology for top-down design practices so that whenever you're faced with problems, such as the 20,000 different components within the assembly, or even the 200, you're able to tackle those with ease. And so these changes, they can be costly and time-consuming, so we're trying to rectify those. They're hard to swap in and out of parts. I kind of touched on this before with the talk track that I was talking about before. And also, this is another really good point that I like to talk about. Sometimes you have engineers that they send out works to other vendors, right? And you say, okay, here's our list of requirements. We only want you to work on this specific section. But as your company, you don't want to be sending out your intellectual property. So you want to have the ability to just send them just enough information so that they can go ahead and create whatever part is necessary without seeing all of the data that is potentially your intellectual property. You don't want to send them all that. You just want to send them work so that they can create and then back the correct part to you, and you can implement that into your assembly. And you need to do it fast, and that's kind of the name of the game. You want to get your stuff out to market faster so that you can sell more, you can have a better product out to your customers, and ultimately just grow your business. So that's where the advanced assembly extension comes into play. This is an extension that gives you the tools and the methodology for top-down design so that you can implement assembling many different components, whether it's 200, 20,000, 200,000 different components, having those assembled very easily, and also enabling you to share out data to multiple different sources without having to compromise your intellectual property. And I know all of this is kind of abstract right now, but I'm going to go into my capabilities to kind of fine-tune what I'm talking about. And within the demonstration, it will really shed light on what I'm talking about as well. So let's jump right in. So the name of the game here is top-down design. So this is a methodology that we like to promote here at PTC that enables you to build from a top-down level so that whenever you're creating your parts and you want to make references to other parts, they interact together seamlessly. So let's say, for example, we have this helicopter and we're looking at making changes to the doors, right? So if we design with a top-down approach, if we want to make design changes to the door, let's say we want to use different features for it, it wouldn't matter because our model will automatically accept that because we have those references in place, because we have those relationships in place. That's really what the top-down design is really talking about and speaking to. So this is going to enable you to do things like part placement, geometry sharing, swapping in and out parts like this. This can also spread out to mechanism design as well. Let's say you have a general path that you want your tool to be placed on. It doesn't matter what parts are in there. As long as you have that design intent, you can swap them in and out very easily without worrying about your model breaking or things failing. So a lot of this works off a skeleton model. So the skeleton model is a very special type of model, and it's something that's going to reside right in the top of your tree here. So what this contains is all the key information for your design intent. So it's going to hold all the location and interference information, just kind of getting you started whenever you're creating a model. And it's always going to be the first component within your model tree. And importantly, it's not storing any data like mass properties or anything like that. So it's not going to show up in your bill of materials. It's not going to show up in anything like simulate or any type of simulations that you're trying to run. Any mass properties, anything like that, nope, not going to show up there. All it's holding is the key design information in which you're going to build off of. So I keep harping on this top-down design and the importance of having references and relationships and now incorporating the skeleton model in which they're going to reside. So another thing that the advanced assembly extension gives you is a reference control that allows you to manage and limit your component references. So there's a couple different ways you can manage these. There's one way with the PTC Creo parametric options. You can see there's many different ways that you can manage your references, such as you want a reference creation and backup control. You can say all components, some components. You can toggle each of these individually on and off. In addition to that, you can do something which I think is pretty cool, the reference viewer. So this reference viewer is going to show you the parent and child relationships to each of the parts, sub-assemblies, and top-level assemblies that you have within your session. So you can see here, here's an example here. We know that we have this aperture, it's a sub-assembly, and you can see how this is related to each of the different parts or top-level assemblies and even sub-assemblies as well. And you can determine and basically filter what you want to see. So you can change the scope, change the status, change whether it's a weak or strong reference type. You can change which reference types are being shown as well if you want regular placement relationship. What I'm getting at is there is a lot of control here that you can utilize to see exactly what the references are and how they impact your model. Also, you can utilize inheritance models. So this is one-way associativity. So let's say you pull in a model, but you don't want to make modifications to that model directly. You can use inheritance, grab all that geometric information, and then make modifications down the line. So it's one-way associativity. You can also do interchange groups, which allows for instant swapping of components. So instead of recreating the wheel, you can simply have, let's say you have this fuselage here and you want to swap out this midsection. Instead of having to finagle with this entire assembly and try to get the references right whenever you assemble it in, you can simply just swap them out very quickly and easily, and it'll even take into consideration things like length, width, all those different dimensions, and adjust accordingly. You can also do merge and cutouts. Now this is something that a lot of people are talking about. So traditionally, if you wanted to do a merge and cutout, you'd have to take your block from what you're working with, create a quilt with a whole bunch of different surfaces, and then determine, whether you want the surface to be in the positive or negative in which you're cutting out. But now what you can do is take two solids. So you can see this is a solid block. Here's another component that we assembled within Creo. I can take those two, merge them together, even though they're solids, and say, okay, I want this to be the negative, I want this to be the positive, and then cut it out like so. So it makes that so much easier than the traditional methods. So before I go any further into any of the other slides, let's actually jump into the demonstration, and we'll get our feet wet within the software so I can show you a little bit better how you can utilize something like this. So for this example, we're going to use a pretty complex assembly model, and we're going to utilize a train. So with this train, there's a lot of different components that go into working with this. You got your seat placement, you got all of the stuff that's going to run the train, all of your engine components and whatnot. You got the wheels, you got the basic cabin, you got windows, what have you. There's a whole bunch of different things. So I want to utilize AAX, our advanced assembly extension, to begin work on each of these different components. So one of the first things I'm going to do is I'm going to publish geometry so that I can send this to other engineers to work on their components concurrently, and then have us all sync up at the end and all of it come together very nice and smoothly. So let me show you how we do that. So first I'm going to go into my published geometry, and I'm going to select some parts. So let's say I have an engineer who is just working on the cabin, right? So I'll grab things like the envelope in which it's residing. I'll grab the window, the door frame, things like that, and I'll publish that. And as I publish that, that's going into my model tree as well. So let's do another one. Let's say I have another engineer who is doing the seats, right? So they are going to need some information like the boundaries in which it's going to reside and maybe some other details. So I'm going to grab that and I'm going to publish that out so that they can grab just that information, just basically the envelope information and some scaling information, so that they can go ahead and create the parts that they need without me having to send them the entire model. Like I said, this is a huge model. So even though this is internal to my company, you know, having to load something like this in and out is not going to be fun. I just want to be able to send them small chunks in which they can create their parts that they need, and then they can send it back and all of it come together seamlessly. And again, this kind of goes back to what I was saying before with protecting your intellectual property. You could do the same thing that I'm showing you here, send this out to vendors, they can create their parts, and then you can bring it all together seamlessly as well. So let's just keep moving forward here. So that's, we have one that's for our structure, one for the interior. You can see this is residing within our model tree. And we're gonna do another section here. So if we go in, we now are gonna copy that geometry that we just published so we can share it out as well. So we have that for structure, and I'm utilizing copy geometry. And you can see as I go into my sub-assemblies, we look into our interior, we have our interior skeleton model. And again, that's just utilizing and showing all the design intent. And so I can copy that published geometry for the interior and paste it into that sub-assembly. So you can see it now has a copy geometry ID of 386. So I did those for both parts, for the structure and for the interior. So here's an example of 4 engineers working concurrently on the same model, but just focusing on specific parts. So as they're working concurrently, they're going about their daily lives as design engineers, but they're only working from information that is absolutely vital, right? You can see it's pretty barren here. All of these are just showing parts that I, from that published geometry and the copy geometry that I showed you. So things like just the interior, or just the door frames, or just the windows, right? And so from this information, we can go ahead and have multiple engineers build out whatever they need to build out, such as windows or seat placements, table placements, what have you. And then once all of their work is done, they simply just save it off, send it off, and the main, let's say the top engineer, design engineer, can then take all of that information and incorporate that into the top level assembly. So once all of this is done, you can see we're still doing things like patterning, we're doing different types of extrudes, we're pulling in more data, you know, anything that we can do within Creo, we can do within here, of course, and all of that is going to make sense. So you can see even down at, you know, in this specific window, we have a pattern going on, right? Where we have, you know, about 8 different instances of window placement or seat placement, things like that. But because this is referenced off of the geometry that I published out, if there was a design change where we only had space for 6, that's going to update accordingly, and our whole model isn't going to explode. I'm sure, you know, there are a lot of people who, you know, they don't have the design intent down, and they've run into instances where, you know, a simple design change like that, changing the instances, has their whole model blow up in their face. And that's what we're avoiding here. So let me show you an instance of that. So for this specific one, we have a design engineer who is working on the placements of the seats and tables, right? And let's see what happens when we incorporate that into our entire model. So we're simply going to do an update. And then with this one, we can check and see if there's any interferences here. Now, based on this, you can see there is an interference, but because we have our design intent in place with the skeleton models and with the top-down design practices in place, making this change is not going to impact our model in a negative fashion. So we have this distance here of 350 millimeters. Now, when we go in and we make this change, instead of it having references to, you know, parts in our subassembly that are going to just negatively impact this change, we just have it saying, okay, well, we have a reference to the bottom of the floor and to the top of the seat. And now when we make a change here, instead of going 355, we simply go 350, you know, now our model is good and our whole model didn't blow up. and you can see that interference is no longer in place. And now as I update the model and I pull in those different instances, you can see from that pattern, we're not going to have any issues. And that's the name of the game, being able to work concurrently with different engineers, implementing top-down design techniques, and also utilizing things like skeleton models and published geometry and copy geometry so that we can seamlessly work together concurrently to create our product much more efficiently and much faster. So that's basically a really good high-level overview of how you can utilize our advanced assembly extension. I know this was a relatively quick demonstration, but that's basically just how you would utilize it in a day-to-day fashion. From here, I just have a couple more slides, and of course, if you guys have any questions, feel free to type them out and we'll go from there. So at the end of the day, what's the value of the advanced assembly extension? Well, number one, I'm sure you could have seen from that demonstration, it's drastically going to improve your performance. You're going to have less time dealing with the models, and it's going to enable you to have more time designing. That's what design engineers do. They don't want to have to worry about, having the most up-to-date model or worry about their designs crashing. They just want to go and design. So this is going to enable them to do that. It's also going to enable you to make design changes with confidence, right? This is what I was talking about before. Let's say if I want to swap in and out these parts, instead of me worrying whether this is going to impact the top level assembly in a negative way, I can simply just change these out and not have to worry about it. It's going to enable us to have efficient reuse of our models. So all of that legacy data, instead of throwing that all away, we can simply implement our design techniques, implement those legacy data, and we can put that into our further models as they come out in the future, instead of wasting time recreating the wheel. You're going to be able to work collaboratively, both internal and external, and it's going to enable you to protect your intellectual property, which I showed you in that demonstration. And at the end of the day, you're going to have better quality, customized products that are going to go out to your customers faster and at a much less cost than your competition, because you're able to design in a very competent, efficient, and fast-paced level. So that's what AAX is in a nutshell, and that concludes my presentation. Again, like I said, if you guys have any questions, feel free to put them up in the chat, but at this point, I'm going to pass it back over to Rob, and we'll go from there.
Nicely done, Jonathan. Thank you. So what I'm going to take back control. If anybody has any questions, they can submit those questions at this time. But also, I want to ask Joe DiCarlo if Joe has anything that he wants to add about the top-down design process and what his customers have experienced utilizing the advanced assembly extension.
Thanks, Rob. I think one of the biggest benefits we've seen from our customers, not only being able to work with skeleton models, which gives you a much more cohesive look at the entire assembly and a much easier way to change the assembly once you might have some late-stage design changes, is what was mentioned briefly, but I'd like to explain a little bit more, what's called copy geom. So typically when engineers are modeling or putting parts together, you're going more like the Lego approach, where you design a part, you design a second part, you figure out how you're going to fit them together, or you kind of eyeball it and reference it on the screen, but you still have to tweak and modify a little bit to get these parts to fit together correctly. What copy geom allows you to do inside of the advanced assembly extension is really leverage the design intent and geometry from one part to other mating parts that might be used in the assembly. A good example is a pump with a flange. So you have a flange with a certain bolt hole pattern, and now you have to make the mating pump part to that flange. Well, instead of designing a new solid model for the mating part, you simply collect up all the surfaces on the original pump part, including the hole pattern, and use that as your starting point for the second part. Now what happens is, if there's any changes to that original part, if, for example, the bolt hole pattern changes, not only does the pattern change on the second part, but anything that's assembled to it. So nuts, bolts, washers, all of that updates automatically, and it does flow down to the bill of materials. So now you have a correct accounting for all the parts in your assembly generated automatically from the system.
Good explanation.
That's it.
Excellent. So one of the things that we want to make everyone aware of is that PTC, as you probably know and have heard, they're moving to a 100% subscription model as of January 1st, 2018. This means that perpetual licenses will no longer be available. So for those of you who are on a perpetual license, if you're using Foundation XE, or if you're on Creo Parametric, you will not be able to move up to the Creo Essentials platform, which has capabilities like flexible modeling and freestyle. You will not be able to move up to that platform after January 1st. So the other thing about these, I guess what PTC is doing is they're giving an incentive to help people upgrade at a 35% discount for the remainder of the year or until December 28th. So even if you are currently on Creo Essentials, you can move up to Creo Essentials Team, which has the Advanced Assembly extension as part of Creo Essentials Team. So what we would do is we would discuss with you the other aspects of what's included in Creo Essentials Team and see what makes sense and what the I guess the best financial option would be as far as upgrading is concerned. Now, these upgrades are not just only for the Creo Essentials packages, but also the Creo engineering packages, which have some more sophisticated extensions available. So if you're interested in any of these offers, or if you want to know more about the Advanced Assembly extension, you can contact us toll free at 866-624-3HTI, or just send us an email at info@3hti.com. My contact information is here, or you can just reply to the emails that were sent to you for these webinars, because if you reply, they will come directly to me. So I want to thank Joe DiCarlo and Jim Gilmore for being on today, and also Jonathan Conklin from PTC. Appreciate your time and your help, guys. And I want to thank everybody else for being a part of our webinar today and taking a little bit of time out of your day to learn more about 3HTI and the Advanced Assembly extension. So this is going to conclude our webinar. Thank you, everybody, and have a great weekend.